recorded. So this is BVLSI lecture number 25 online. Alright. So yesterday we have solved one numerical on um, NMOS transistor. Okay. So today we'll solve one more numerical on threshold voltage for a PMOS transistor. So let's read out this numerical. A PMOS transistor is fabricated. So first of all, let us write it is a PMOS transistor. Okay, so if it is a PMOS transistor, what is the type of substrate? The type of substrate is N silicon substrate. Okay, so just remember that. Okay, so yeah, PMOS transistor was fabricated on an N-type substrate with a bulk doping density of 10 raised to 16. Now, what is 10 raised to 16? Can you tell me? Na or Nd? Yes, N-type substrate. So it will be Nd is 10 raised to 16 per centimeter cube. Further, gate oxide thickness is 500 angstroms. So gate oxide thickness is Tox is 500 angstroms. First, let us write the given data. Number of fixed oxide charges are 2 into 10 raised to 10. So that is NOx. Number of fixed oxide charges 2 into 10 raised to 10 per centimeter square. A metal gate is used for the PMOS transistor. So we are using a metal gate. Okay. Number of surface charges are 0. So NSS is 0. Alright. So we have to determine the threshold voltage under 0 substrate bias at room temperature. So basically we need to find VTO. Okay. And also we have to determine the threshold voltage for substrate bias equal to minus 1 volt. Okay. So we have to find VT for VSB equal to minus 1. So that's the given data. Now let's bring that into full screen mode. Yeah, so how will you solve this? So first of all, write the data in the form where everything is clear. So let's say we will write TOX in the form of centimeters. So what is 500 angstroms? 500 into 10 is to minus 8 centimeter. Alright. And what are units we have to remember? So the first unit is epsilon OX of silicon. So there is 3.97 into epsilon naught, permittivity of free space. What is epsilon naught? 8.854 into 10 raised to minus 14 farad per centimeter. Then permittivity of silicon is 11.7 epsilon naught. That comes out to be 10 raised to minus 12. Alright. Then what do you remember? Ni. Ni is 1.45 into 10 raised to 10 per centimeter cube. Then what do we remember? Kt by Q. How much is Kt by Q? 26 millivolt. So we should remember all of these quantities even before we start with the numerical. Sometimes they give, sometimes they don't give this quantities. Okay. So in cases if they don't give, we have to determine these quantities in the first hand only. Alright. So now we will write the threshold voltage formula for PMOS transistor. So let us start with the solution. So solution. We have written this given data. So ND is given, TOX is given, NOx is given, NSS is given. Metal gate is given. So if metal gate is given, what is my phi f gate? Can you tell me? So phi f gate will be how much? 0.55. That is what we told. We will assume this number. Okay. So for a metal gate, the value is 0.55. If it is a polysilicon gate, then we will calculate. Alright. So let us start with the solution and write down the formula for the threshold voltage. The formula will remain the same. So VTO equal to phi ms minus 2 phi f substrate minus QBO upon COX minus QOX upon COX minus QSS upon COX. Alright. So out of this, QSS is 0 because QSS will be Q into NSS. So number of surface charges are 0. So this will be 0. So this term will be 0. Okay. Alright. Can we start to the next part? Okay. Next we find out the value of QOX. So QOX is Q into NOx. Okay. The value of Q also you should remember, it's 1.6 into 10 raised to minus 19 into NOx, which is 2 into 10 raised to 10. So how much is this? 3.2 into 10 raised to minus 9. What is the unit? What is the unit of QOX? Coulomb per centimeter square. Alright. Now next we find value of COX. So COX is epsilon OX upon TOX, gate oxide thickness. What is this? 3.97 into 8.854 into 10 raised to minus 14. I think we calculated this number yesterday also, but still it's good for calculations. We write it again. So how much was this number? COX number how much in terms of 10 raised to minus 9 farad per centimeter square? COX was how much yesterday? Same TOX is there. It was COX gate oxide thickness. What's the value? Hello. Could you tell me the value please? Gate oxide thickness. Divide this number. Yeah, 70.3 into 10 is to minus 9. Correct? Now we will calculate phi ms. So what is phi ms? Phi f substrate of the substrate, Fermi potential of the substrate minus Fermi potential of the gate. Okay. Now what is Fermi potential of the substrate? Fermi potential of the substrate means what is the substrate made up of? N-type silicon. Okay. So we have to calculate phi fn. Okay. So what is the formula for phi fn? Kt by q natural log of, remember the formula, Nd upon Ni. So let us substitute the values over here. 26 millivolt into natural log of Nd is 10 raised to 16 divided by Ni 1.45 into 10 raised to 10. So here what is changed? This is what is changed for a N silicon substrate. So let me know this value phi fn, how much it is. This number will be positive volts. So let me know this number, how much it is. So 26 millivolt into natural log of 10 raised to 16 upon 1.45 into 10 raised to 10. So what is the magnitude you get over here? You will get a positive number for phi. 0.3495. Yeah, okay, alright. It is correct. So here phi ms will be phi fn minus phi f gate for metal gate. So this will be 0.3495 minus phi f gate is assumed to be 0.55. That is what we have assumed. So how much is this? Work function potential between metal and semiconductor, how much it is? Phi ms minus minus 0.2. Okay. Alright. So work function difference is minus. That's fine. Next, what do we find? Acha, twice 5 substrate. So what will be twice 5 substrate? 5 substrate will be this only. Okay, so this is actually equal to 5 substrate only. Okay, so double the value we will put it over here in the formula later on. Now only thing left is to find the value of QBO. Okay, so let us find the value of QBO. What is the formula? Remember, in case of N silicon substrate, this value is positive. Remember this. So inside also there are some changes. Q, 2Q, permittivity of silicon into ND mod of minus 2 or twice 5 substrate. Okay, so let us substitute the values one by one. Square root of 2 into Q, 1.6 into 10 is to minus 19. This permittivity of silicon will be, we have calculated 10 is to minus 12, and these 10 is to 16, and twice 5, here it is 2 into 0.3495 mod of it. So let me know the value of QBO. What is QBO called as? QBO is called as depletion charge density. How much is this? Can you tell me? Plus. You have to be careful with your calculations. That's the only hint you can, remember your formulas and be handy with your calculations. This also tell me in the form of 10 is to minus 9. This will be coulomb per centimeter square. So tell me the value. 47 point, sorry, 29. Okay, yeah, that's correct. Now we will club all the terms together. So let us rewrite. So I hope you have completed up till now. You're solving along with me. So VTO will be phi ms minus twice phi f substrate. The reason for writing the formula is so that it becomes a part of you. Then minus QBO upon Cox minus Qox upon Cox. No need to write QSS upon Cox because that term is 0. Okay. So let us plug in the terms over here. What is phi ms? Minus 0.2. So this will be minus 0.2. Be careful, huh? Then minus twice phi f substrate. Phi f substrate is 0.3495. So how much will be this? 0.699 if we calculate it. Then QBO will be positive number 47.29 into 10 is to minus 9. So 47.29 into 10 is to minus 9. What is Cox? Cox is 70.3 into 10 is to minus 9. So please write it down. 70.3 into 10 is to minus 9. Qox is 3.2 into 10 is to minus 9. This will be 70.3 into 10 is to minus 9. Okay. So 10 is to minus 9 terms gets cancelled out and you're left out with this expression. Remember, threshold voltage for the PMOS transistor will come negative. That's your clue. So minus 0.2 minus 0.699. How much is this fraction? 0.673 minus 3.2 upon 70.3 is 0.0455. Okay. So let me know the value of VTO. How much it is? Minus 1675, right? Yeah, correct. It's absolutely correct. So this is the threshold voltage for a PMOS transistor. Okay, with zero substrate bias, with VSB equal to 0. All right. Numerical is complete, 70% complete. Still, we have to calculate threshold voltage with VSB equal to minus 1. Everyone completed up till here? Okay. So we have to go very patient, and we have to be dealing with the calculations very patiently. Any deviation in any one answer will lead to a wrong result. Now VTO can be is a number. It will be maximum between -2 to maybe 1 or 2 volts for PMOS and NMOS transistors. Okay, are we ready for the next part? So next we have to calculate threshold voltage VT for VSB equal to -1. So let's do that. Okay, so second part will be you have to calculate VT at VSB equal to -1. So what was the formula we used? VT equal to VTO plus eta into square root of mod of -2 phi f plus VSB. This will be minus square root of mod of -2 phi f. I think this was the formula, right? And what was the value of this eta term? What was the formula? Square root of, it will be changed and it will be negative. Remember, there will be a negative sign because of N silicon substrate. For PMOS transistor, it is negative. So 2Q permittivity of silicon into ND divided by Cox. And the good news is this number will be between 0 and 1 only. So let us substitute the values. 2 into 1.6 into 10 raised to -19 into 10 raised to -12, and D is 10 raised to 16 divided by Cox, which is 70.3 into 10 raised to -9. Calculate this number. It will be between 0 and 1 always, and the unit is square root of volt. Anyone with the answer? Take your time for calculations, no problem. Completed? How much is this number? Yeah, 805 something. Yeah, 8046. Yeah, that's 805. Yeah, 1099 8046. All right, correct. Now we substitute it in the original formula. So this will be VTO plus. So let us directly substitute it over there. So above we can see the formula, right? VTO. So what is VTO? How much is VTO? Minus 1.6175, right? 6175. Then this plus will come. This number is minus, remember. Then into square root of. Okay, interestingly, what will come over here? Minus 2 into this number will be 5 is 0.3495. So this will be 0.699, and VSB is minus, so -1. Mod of, this is mod. Minus square root of mod of this number is 0.699. Okay, now calculate this and let me know the answer. This is 1 minus 1.6175. This will be minus 0.8046 into, what about this number? 0.4674. So can you tell me the final answer for threshold voltage? It will be even lower than this. Our original answer was minus 1.61. It will be lesser than this. Lesser means it will be lesser than minus 1.61. How much is the answer? Minus. Okay. I'm getting 2.0. Anyone got 2.0? 1.99 or 2.0? That both will do. 1.99 what? So minus 1.993, that's close enough. Or anywhere near to, see, all the answers are accepted, plus or minus 5% is allowed, deviation is allowed. So 1.9 something to 2 point something we can accept. So these answers are accepted, plus or minus 5% deviation is allowed. Because some of you all take after point only 2 decimals, some of you all round off, some of you all take 4 decimals. So it depends upon the students. So that's why this range is given. Okay, yeah. So everyone got this answer. Some of you all may get minus 2.0, right? So that's fine. Can we go to the next one now, everyone, students? Hello. Okay, so this will be just a practice now for you all. We have solved the two numericals required. Now it might be given in the different form. So let me open the document. This is one textbook numerical. So this numerical number one is given over here. Well, we will solve it later because this involved threshold voltage adjustment, which we have not covered so far. We'll solve another numerical. This also is like, you see, it's a PMOS transistor fabricated on an N-type substrate with a bulk doping of 10 raised to 16. So we have been given NDS 10 raised to 16. Here, gate doping density is given 10 raised to 20 per centimeter cube. Qx upon Q value is given. So that is fine. We'll come back to this. First of all, we'll solve another numerical. This one. No, that is also fine. We can find that also. Let's solve this only. So let us solve numerical number 2 and let us write down the given data. Again, we have a PMOS transistor. So what do you mean by PMOS transistor? What is the type of substrate? N silicon substrate. Okay. So N silicon substrate with a bulk doping density. So what is this? ND. ND is 10 raised to 16 per centimeter cube. With a bulk doping density of 10 raised to 16 per centimeter cube. Gate doping density, N-type poly, is 10 raised to 20. So what is this? We are using polysilicon. Gate doping is given to you. Okay. So we can write ND poly. This is polysilicon gate doping density. So ND for gate. How much it is? 10 raised to 20. 10 raised to 20 per centimeter cube. So directly it is not metal gate, it is poly gate now. And it is given Qox upon Cox is given to you. So Qox upon Q. Qox upon Q is given to you. How much it is? 4 into 10 raised to 10 centimeter square per centimeter square. Thickness is given to you. Hello. Go ahead. Gate oxide thickness is Tox. How much? 0.1 micrometer. Alright. We have to calculate the threshold voltage at room temperature for VSB equal to 0. So we have to calculate VTO. Alright. And we have to use this formula epsilon S or silicon. Sometimes we write epsilon S or epsilon SI. It's 11.7. So that is what we use normally. Okay. So this is the given data. Shall we solve this? Yeah. Let us start. Okay, let me put it to full screen and let us quickly calculate this. Okay, so first of all, we have to understand the given data, what it is. First of all, we have to write Tox in a standard form. So this is 0.1 micrometer is 10 raised to minus 6 meters. So how many centimeters can you tell me? Meters into centimeters, how will you write? This will be 0.1 into 10 raised to minus 4 centimeter. Okay, 1 meter will be 100 centimeters. All right, qx upon q is given to you. We have to find uh, VTO. Okay, so let's start writing the solution. So what's the formula for VTO again? Phi ms minus, this is different, huh? This numerical is slightly different. So that's why I am writing it again. You indirectly, y'all are, for your revision is happening. So minus QBO upon COX minus QOX upon COX. Alright. So QSS is not given, so assume NSS is equal to 0. Okay, surface charges are 0. So no need to write QSS upon COX. Alright. So here let's start finding these values. So first of all, what you wish to find? QOX, right? But you will say, sir, QOX upon Q is given to you. Alright. This is given to you. So how will you find QOX? Anyone? How will you find this? This is given to you. Per centimeter cube. So QOX will be Q into this, right? Q into 4 into 10 is to 10 coulomb per centimeter square. So find out this. How much is this? 1.6 into 10 is to minus 9 into 4 into 10 is to 10. So how much is QOX now? 4 into 1.6 is 6.4. So 6.4, this is 10 is to minus 19. Huh? Sorry. 1.6 into 10 is to minus 19. So this will be 10 is to minus 9 coulomb per centimeter square. Alright. So that's my value of QOX. Let us write the standard values once quickly. So standard values are epsilon of silicon is 11.7 times epsilon naught, which is around close to 10 raised to minus 12. Permittivity of free space is 8.854 into 10 raised to minus 14. For oxide it is 3.97 epsilon naught. Then Ni is 1.45 into 10 raised to 10 per centimeter cube. KT by Q is 26 millivolt at room temperature. So these are all the constants, we will be using it. And of course Q is 1.6 into 10 raised to minus 19. Okay, next we will calculate COX, right? So what is the COX? Epsilon OX upon TOX. So this is 3.97 into 8.854 into 10 raised to minus 14 divided by, how much is TOX given to you? So numbers are different. 0.1 into 10 raised to minus 4. So 0.1 into 10 raised to minus 4. So calculate this number and let me know. Please calculate in terms of 10 raised to minus 9 farad per centimeter square. It's gate oxide capacitance. So let me know the value of COX. How much is COX? Yes, correct. 35.15 is correct. Alright. Next, what we need to calculate is phi ms. Be very careful, this is new. So this will be phi f substrate minus phi f metal or this gate, right? So phi f substrate will be, I am calculating separately. Phi f substrate will be what? Phi f n or phi f p? See, this is n type substrate. So we have to calculate phi f n. What is the formula? KT by Q natural log of Nd upon Ni. So please calculate this. So phi f n will be 26 into 10 raised to minus 3 into natural log of Nd. Nd is how much given to you? Nd is 10 raised to 16 upon 1.45 into 10 raised to 10. I think we have calculated this before today only. How much was this formula? This is plus 0.3495, right? Something like this, correct? With the same doping, we have calculated this today. Yes or no? Yep. Are you getting the same result? Now, a crucial thing is you have to calculate this phi f gate. So see what I am writing. Phi f gate is made up of what? Let us see. It's made up of polysilicon with a doping of 10 raised to 20. So this will be phi fn of gate. So its formula will remain the same. Kt by q log of, but Nd will be Nd for the gate divided by Ni. Okay. So this will be 26 into 10 raised to minus 3 into natural log of, what is Nd of gate given? 10 raised to 20 divided by 1.45 into 10 raised to 10. So this will be my phi of gate. So tell me the answer for this calculation. Because here it is metal gate is not given, so we have to calculate this way. So please remember, we have to calculate it this way. 0.5890. Yeah, that's correct. This is correct. Okay. So calculate phi ms. Phi ms will be phi f n minus phi f gate, which is 0.349 minus 0.589. How much is that? Minus 0. How much? Minus 0.24. Yeah, that's correct. Yeah. So now only thing left is to calculate QBO. So let us calculate QBO. See, remember, this gate doping is only required for phi of gate. For all the remaining things, we have to calculate phi of substrate, which is this only. Okay. So this formula, in this formula, 2 phi of substrate. This is substrate ka doping. So this 2 phi substrate will be 2 into 0.349. Remember that. Not this number. This number is already used now. Okay. Next is QBO. I told you for N silicon substrate, QBO is positive. Square root of twice Q Nd epsilon of silicon mod of minus 2 phi f. यहाँ पे भी substrate. Here you will have substrate. So QBO will be equal to square root of 2 into 1.6 into 10 raised to minus 19 into 10 raised to 16 into 10 raised to minus 12 into 2 into 0.39 0.349. This we have calculated before. How much was it? Somewhere close to 40 something, right? Into 10 raised to minus 9. Tell me in terms of 10 raised to minus 9. 10 raised to minus 9 coulomb per centimeter square. Alright. So this formula also we got the answer. Now plug in all the terms together. So we finally write VTO equal to, VTO equal to phi ms minus twice phi f substrate minus QBO upon Cox minus Qox upon Cox. Okay. So VTO will be equal to phi ms is how much? I think minus 0.24 minus 2 into how much is phi f substrate? 0.349 minus QBO is 47.29 into 10 raised to minus 9 divided by Cox is how much? 35.15. Yeah, 35.15 into 10 raised to minus 9. If you're getting any other numbers, I mean, if you're getting the randomly drastic number than this, that means your calculations are slightly wrong. Qox is 6.4 into 10 raised to minus 9. divided by 35.15 into 10 raised to minus 9. So 10 raised to minus 9 gets cancelled out. You follow exactly the same method which I am using, you will never go wrong, provided you write the correct polarity. So minus 0.25, this is 0.699 minus 1.368, 47.29 divided by 35.15. 6.4 divided by 35.15 is 0.182. So how much is the answer? VTO will be negative. 2.466. Yeah, that's correct. Range is correct. If you're getting minus 2.4 something, minus 2.3 something, minus 2.5 something, that's correct. Okay. Alright. Everyone got this answer? And this is for the PMOS transistor. Remember, for the PMOS transistor, the threshold voltage is negative. PMOS transistor with VSB equal to 0. Alright. Now, we go over here in this document and try to write the data only for this. Okay, now let me write the data over here itself. This document I'll share it with you. For time being, the second part is not to be covered because that is not there for your ISC exam. Only part A is there. So TOX is given 500 angstrom. So how will you write TOX as 500 into 10 raised to minus 8. Let only writing the data, that's it. Nothing else. I'm not solving this. Substrate doping. So Na is given to you. This is for NMOS. So we have P silicon substrate. Remember it. So Na is 10 raised to 16 per centimeter cube. Now, polysilicon gate doping Nd is given. So Nd of gate is how much? 10 raised to 20. So same way as we have calculated, we have to calculate phi f gate. Okay, with this doping level. NOx is given to you 2 into 10 raised to 10 per centimeter cube. You have to calculate Vt for an unimplanted transistor. So we have to calculate Vt over here. Your substrate bias is not given. So you have to calculate Vt. So you can check out this solution and you can cross check the answer. It come out to be 0.14. So you can solve this later for your exercise. The answer is 0.41. Without looking at the solution, directly answer I am telling you 0.41. So you can cross check this answer later on. Alright, everyone. Now let me show you one more. Okay, so this document I will sharing today. Let me show you one more test part which has come in the, I guess, in one of the ISC exams, January 23, May 23. So let us see how it has been asked in the exam. This is asked for 10 marks. So a long N channel enhancement mode MOSFET has the following device parameters. So let us write the parameters over here. Okay. So this is numerical number 3. We write only the parameters. We are not solving this. So parameters is it is N channel. N channel means it is NMOS. So if it is NMOS device, that means what is my type of substrate? P silicon substrate. So you write it down in your in your papers first of all. Then TOX is given. How much is TOX? 400 angstroms. I told you these parameters will deviate slightly. So it will be 400 into 10 raised to minus 8 centimeter. This conversion you should know. Then Na, substrate acceptor doping. Na is given to you is 1.5 into 10 raised to 16. See, not much difference. Then gate donor doping. So what is it? Nd gate. Okay. So phi f gate we have to calculate using this doping. 10 raised to 18 per centimeter cube. Then QOX is given. QOX is Q into pi into 10 raised to 10. So basically we have to substitute the value of Q over here. Sorry. It's coulomb per centimeter square. It's area. Then epsilon OX is given to you. See this, sometimes they give this number. This we already knew, right? 3.97, and this silicon is 11.7. So for this, we have to calculate XD. Now XD formula we have, I think we have calculated it before, right? You'll have written it down, right? 2 lectures back. XD we have to calculate. You have to calculate QBO. You have to calculate COX. We have to calculate QOX. And we have to calculate threshold voltage. So even if the threshold voltage formula comes wrong, even if your intermediate steps are correct, that means COX is correct, QOX is correct, you will definitely get marks. Okay, so if there are 5 parameters asked, I will give marks, 2 marks for each of them. It's actually given this way only, see, 2 marks for each of them. So final answer will have only 2 marks, intermediate should be correct. Now anyone can tell me what was the formula for XD? XD is a depletion region width. We have calculated it 2 lectures back. Remember, 23rd lecture. Let us check it out. Yeah, what was it? XDM. This is XDM, but what is XDD? Can anyone cross check? This is the formula. Square root of twice epsilon mod of phi f divided by q na. Can you confirm? Because this is XDM, this is maximum width, but XD is this much in centimeters. Can someone cross check it? We have discussed it while deriving. Let me check one of the PDFs. XD formula. Yeah, it is psi x. Correct, absolutely correct. This formula is correct. And rest all the formulas you know. So can you easily calculate these numbers, everyone? Just as an exercise for practice. Yeah. So only thing is, only careful thing is that is I'll write it down. Phi ms will be phi f substrate minus phi f gate. So this phi f substrate you calculated normally. So phi f substrate will be phi f p, which is kt by q natural log of, what will you write, ni upon na. Remember the formula again, and this will be coming negative. So this na will be this number. Okay, but phi f gate, what will be the formula? Kt by q ln of nd of gate, doping of the polysilicon gate, upon ni. Only you have to make sure that this number is 10:18. That's it. Remaining steps are as it is. Alright. So this is the only clue or only problem which students face. Metal gate is not given, their doping is given to you. So we have to calculate the phi f gate formula and then substitute it over here. Remaining all the steps are same. Alright. So yeah, you have any doubts you can ask me, or else that's it from my side. So best wishes for your exams.